Hello, my name is Oscar Ailson. I am a chemistry student here at WNMU. And my project for the last summer was a study of the creation of ferrofluid and its components. The goal of that project was to create a review of ferrofluid synthesis methods. You might ask yourself, what is ferrofluid? Well, to give a very brief synopsis, it is a stable colloidal suspension of ferromagnetic nanoparticles. Now, not to use too much jargon, and to simplify it for you, that essentially means that there's a bunch of really small magnetic particles that are floating in a liquid. It results in a ferrofluid or a magnetic fluid. The image you can see there is what that looks like, or what a ferrofluid looks like when it's under a magnetic field. It generates spikes and it can be controlled. So you can move it around in a dish or in various different components, which is one of the reasons why its applications are very important, because there's not many liquids that can perform the same way that ferrofluids do. So on a molecular scale, this is essentially what it looks like. This was adopted from Raj K. The little black centers that you see there are the magnetic compound or the magnetic particulate. They're primarily composed of iron, as I said, hence ferro. The little white tendrils that are kind of jutting off of the magnetic center, those are what are known as surfactants. They are kind of like a soap, so they have a polar and a non-polar end. And they stop the magnetic compound from conglomerating or getting too close to each other and dropping out of the liquid. It allows them to be suspended within a carrier liquid, which are the little blue dots that you see around. So with that short introduction out of the way of what the ferrofluids are and the goals of the project, the original timeline that I proposed is as follows. It was essentially a few weeks of gathering sources and reading materials, creating a account for a program called Mendeley and getting that sorted. I'll go into that further in a second. Reading, highlighting, creating primary outlines, writing and defining out and like an actual outline, and then the revisions and finishing touches near the end. It didn't quite work out as planned. And here in a second, I will show you the better timeline. So the main issue was that the reading took up way more than I thought it would. This is one of the things that took a lot more time, and as it essentially delayed the project more than I thought it would. Originally, I'd only thought it would take about 2 weeks or so to read most of the material. And then writing would be the primary part of it. Gathering the resources would only take a couple weeks. But what I learned is that the more I read, the more that I needed to research, the more that I needed to learn. So the more accurate timeline has it so that after a few weeks of reading, I gathered more sources. And after another week or so of reading, I had to gather even more sources. This was a very valuable lesson to learn and shows kind of the hubris that I at least came into when I first started the project. I thought that from what I knew from an outside perspective, that it wouldn't be too much material that I'd have to gather. But as it ends up, there's always more that you can learn, and any specific subject has an unfathomable depth to it. So, like I have in this little PowerPoint, I will be using this knowledge in future projects. It is so important to understand that there's always going to be more material, and that from what you see from the surface is just a drop in the pond. So this is Mendeley. I was talking about it earlier with the timeline, and why we chose it was because Dr. Medina was familiar with it to begin with, as well as because this was this project took place during COVID. there was no chance that we'd be meeting each other. So it all had to be asynchronous and online, aside from an occasional meeting once a week. Mendeley was perfect for that. It essentially is a file sharing and organization program. It also helped with citation. So the picture on the right is essentially what the folder that we used looked like. Each one of those little rows is its own paper, and it has all the relevant information, which you probably can't see because it's a little bit too blurry, but it has the authors, the title, the year, and the publishers. And then whenever you click on the little red icon, it would pull up the actual full paper itself, and it would save all changes you made to it. So if I highlighted anything, etc. I'll show a picture of that in a second. Or actually, it's down there at the bottom left. That is an example of one of the papers that I had read and highlighted. So anytime I wanted to go back and see what I thought was important about any specific paper, it would save all of my highlighting, which was extremely helpful. And Ilya, I think, or Dr. Medina could also see those changes that I made. So the difficulties to begin with were a little bumpy, but they didn't take too long to resolve. It was essentially just that the sharing portion of it was a little bit difficult to get started. And then once that was resolved, it was smooth sailing. In total, I gathered around 135 sources and used Mendeley to keep and organize all of those. So in assistance with Mendeley, I made a small Word document to then reference back to Mendeley afterwards. So this was aptly named my Ferrofluid tracking stuff. It had the DOIs of any paper that I read through, the title of the paper in reference to the DOI, the method for how the nanoparticles were synthesized, what atmospheric conditions, what surfactant was used, and what carrier liquid was used. Then using Mendeley, I would search up either the DOI or the title and then be able to re-reference the paper to look further into any of the specific parts that I was interested in for the actual writing process. Speaking of the writing process, this is one of the first drafts I received from Dr. Medina. As you can see, there was a lot of changes that were supposed to be made or that were proposed, and they were extremely helpful. All of the changes that were made were not always used, but there was always instances where I'd have to rewrite or change an idea, or something was incomplete, or there was improper grammar, or I didn't have the right verbiage or wording on specific instances. It was awesome. Dr. Medina did a great job as a mentor and really allowed me to flourish during the project's lifetime. I'm still working with her, and it's been a blessing really to have her on the project. She's an incredible scientist and a great mentor. So, project achievements. Scientific writing, like I said in the previous section, was a big thing. I didn't know most of the correct methods for talking about a scientific subject. While I do know from the books, and I've done a few projects in school, writing an actual paper with the idea of publishing is a totally different matter, and the wording and vocabulary that needs to be used is a new field that I hadn't experienced before. So I'm much better at that now, and I view that as an achievement. I also now am pretty sufficient at using Mendeley, which is a huge deal. I'm going to use that in most of my future projects and any review that I do later in life, as well as all of my ferrofluid research. I now know a ton about ferrofluid that I did not know previously, of course. Yeah, I wouldn't say that I'm an expert at it, but I'm definitely much more affluent than most scientists. There were, however, lots of complications. I over and underestimated a lot of the workload. As it is my first project, I didn't quite know what I was getting into with some things, and with others, I thought it was going to be much harder than it actually was. there was difficulty for writing for a specific audience. With looking towards publishing, you have to be able to write for an audience that's going to be at least somewhat knowledgeable in the sciences, but also not affluent or knowledgeable about the specific subject you're writing in. So using the correct terminology, but also being able to write it in a way that it's easy to understand and not so dense as most of the actual papers would be. Speaking of the thick material, the difficulty with comprehension of the actual papers that I read was something I didn't anticipate. And this was one of the things where I underestimated the amount of time and difficulty of the project. The material itself was unlike most of what I've read. And because it's such a specific field, there was so many different vocabulary words I just didn't understand or didn't know that I had to learn. And it was really useful because at the end I was able to actually put them into the paper itself and use them appropriately. The project itself was also much larger than 10 weeks. Although we did get a lot done within those 10 weeks, it is still an ongoing project. So the results of it, I can't post really the whole paper because it's 12 or something long pages now. But I can give a brief summary of all of the different main sections. So it was changed, the title, to Approaches on Ferrofluid Synthesis Review. The introduction essentially goes over what a ferrofluid is and how it reacts to a magnetic field, which is unique to it. 1.1 covers magnetic fluids, as there are two primary ones. There's Mahiro. Sorry, let me look up the pronunciation on this. It's always really hard to say. It is magnetorological fluid, and then, or MR fluid, and also ferrofluid are the two primary ones. One being ferrofluid, which is more stable, and then MR fluid being easier to produce but less stable. And they have different reasonings for existing and applications. 1.2 is research and development in ferrofluid. So how it's changed over the period that it was when it was first discovered and today, how it is used. Applications of ferrofluid, biomedical applications being the primary one. There are two primary ones, or two major biomedical applications of it, which is in vivo drug delivery and also in hypothermia treatment. And then the other applications are mostly inorganic stuff. So it's going to be like loudspeakers or I think storage devices is also one of the major ones. So section 2 is synthesis of ferrofluids, which is how the nanoparticles or the magnetic portion of the ferrofluid is created. And the goal being to make really, really small particles that are still highly magnetic, because the smaller the particle gets, the less magnetic it is. So there are three major methods, which is co-precipitation, thermal decomposition, and one-pot. So detailing what those are and the major processes for each of them individually. 2.2 addresses an issue during synthesis, which is oxidation, where one of the iron compounds becomes the other iron compound and it upsets the ratio. So how to compensate for that and how some scientists have proposed solving it. 2.3 covers surfactants. There are different use cases and applications. 2.4 covers carrier liquids, very similar to surfactants, and they actually tie in together because the surfactant you use is tied to the carrier liquid you use and vice versa. 2.5 covers the stability of ferrofluid, which is essentially the culmination of the section 2 synthesis, in which the stability is in reference to the surfactant, carrier liquid, and size of the nanoparticles. And then section 3 is the conclusion and future perspectives. So what scientists are looking forward to, or what researchers are looking towards use cases for ferrofluid. And then number 4, or section 4, is acknowledgements, of course, SRPD and various other researchers and their contributions. And then 5 is references. So pretty standard in terms of an overall outline. So I'd like to give my thanks to, first off, Dr. Bedina, who was, again, just an incredible mentor for this whole project. And then also I'd like to extend my thanks to WNMU's SRPD program. I mean, without them, I wouldn't have done this. I just wouldn't have. But I know that my that me being able to do this was because of them, and also it's an opportunity that not many people are able to do, able to actually take on their own project. Most work under their under somebody else's project, where I got to head this one, which was just an amazing experience. Really, I learned so much, and I am truly grateful for it. But beyond that, thank you all for listening, and I hope you all have a good day. Take care.